A new day, a new discovery in space. Ever since NASA launched its James Webb telescope, it's been capturing outstanding pictures of spatial objects, and it has once again shown off its capabilities to capture distant objects through the most recent pictures of Neptune. Not just that, the telescope captured the ice giant as well as its 7 moons. To find out more, keep watching. First up, Neptune has rings. The powerful space telescope James Webb, which was just launched, has brought back stunning new images of Neptune. Since the Voyager 2 spacecraft passed the planet in 1989, certain details have not been seen. According to the observatory's infrared imaging technology, these consist of the ice giant's rings and dust bands. Yup, Saturn isn't the only planet with rings now. The various cloud forms have intrigued scientists everywhere, and hopefully it should provide them with unique insights into the operation of Neptune's atmosphere. 7 of the giant's 14 moons, including Triton, the most notable, are located outside the planet. In the Webb images, it seems like a star. At the Europlanet Science Congress in Granada, Spain, Professor Lee Fletcher from Leicester University observed that everyone there was trying to interpret the photos on their own. He said it's incredible to see those rings, and we're accessing wavelengths that no one has seen before. He told the BBC News, "It's amazing to see how happy everyone is." The professor explained that with a brilliant equatorial band that resembles the bright bands of Jupiter and Saturn, the longer wavelengths are brand new and may open a window on the deep circulation processes. Heidi Hamnet, a Neptune system expert and a James Webb scientist, said that it's been decades since we last saw these rings, and this is the first time anyone's seen them in infrared. The ring system, according to Dr. Hamill, was completely mind-boggling. That amount of detail has not been seen by me since the 1989 Voyager encounter. Next up, the picture shows 7 out of 14 of its moons as well. 7 of the 14 known moons of Neptune were also captured by Webb. A very shiny point of light with the distinctive diffraction spikes observed in many of Webb's photographs dominates this Webb's latest picture of Neptune. Like everyone would have thought, this object is not a star. It's Triton, the big and weird moon of Neptune. Okay, so for starters, Triton reflects about 70% of the sunlight that it receives, thanks to a frozen coating of condensed nitrogen covering it. Yes, the moons are quite literally wrapped in frozen nitrogen. And then it outshines Neptune by a significant margin in this photograph, because methane absorbs at these near-infrared wavelengths. But as if that wasn't enough, Triton has a weird backward retrograde orbit around Neptune that has led astronomers to hypothesize that this moon was once a Kuiper belt object that was gravitationally grabbed by Neptune. Another fact that might intrigue you a little bit was that beer had a role to play in Triton's discovery, so maybe we can accept that weird behavior. It's also geologically active according to Dr. Hamill, because when Voyager 2 passed by it, literal volcanoes could be seen erupting there. Besides Triton, Dr. Hamill also believes that Hippocamp, the 8th Neptunian moon, can be seen hovering above the planet. She remarked, "It's extremely faint, but it's at the proper place." Moving on, why the blue giant isn't so blue in the pictures. Since its discovery in 1846, Neptune has captivated scientists. The blue planet is 30 times further from the sun than the Earth, and revolves in a remote dark region of the outer solar system. High noon on Neptune is comparable to a dull twilight on Earth because of how small and pale the sun appears from such a great distance away. This planet is an ice giant because of its internal chemical makeup. Compared to Jupiter and Saturn, Neptune is significantly richer in elements heavier than hydrogen and helium. Small concentrations of gaseous methane enable Neptune to appear characteristically blue in Hubble Space Telescope photos at visible wavelengths, which is pretty notable. Even though the gas giant was caught in all its glory by Webb, the blue planet did not look so blue because his near-infrared camera, NIRCam, only sees objects in the near-infrared spectrum between 0.6 and 5 microns. In fact, the planet is fairly black at these near-infrared wavelengths due to the substantial absorption of red and infrared light by methane gas, except in the places where high-altitude clouds are present. Also, these bright streaks and spots of methane ice clouds are noticeable because they reflect sunlight before it's absorbed by methane gas. These rapidly morphing cloud shapes have been photographed by the Keck Observatory and the Hubble Space Telescope. Let's look at the atmospheric conditions of the planet. Neptune's powerful storms can be seen in the picture, and not just that, they appear to be in full swing. Like all the other planets in the solar system, Neptune's atmosphere highly consists of helium and hydrogen gas, but it has a great presence of ice, water, ammonia, and methane. A more clear visual indicator of the worldwide atmospheric circulation that fuels Neptune's winds and storms could be a thin bright line circling the planet's equator. At the equator, the atmosphere lowers and warms, making it glow at infrared wavelengths more than the nearby cooler gases. Due to its 164-year orbit, Neptune's northern pole, which is at the top of this image, is hardly visible to astronomers, but the Webb photographs indicate an exceptional brightness there. Webb's photograph clearly depicts a vortex that has been observed before around the southern pole, but this is the first time Webb has shown a continuous band of high-latitude clouds surrounding it. Moving on to some other news. First up, NASA will provide a media update on Artemis 1 rollback. On Tuesday, September 27th, NASA will hold a media teleconference to explain the organization's choice to roll the Orion spacecraft and Artemis 1 Space Launch System rocket back to the Vehicle Assembly Building, VAB, at NASA's Kennedy Space Center in Florida. Before future crewed missions, Artemis 1 is a flight test that will fly Orion beyond the moon and back to Earth aboard SLS. The agency started to turn back its rocket and spacecraft at 11 p.m. on September 26th, as Hurricane Ian moved near Florida, giving staff members enough time to put their family's safety above protecting the Artemis 1 hardware. To participate by phone, the media must RSVP no later than 2 hours before the briefing. The National Hurricane Center, the U.S. Space Force, and the National Oceanic and Atmospheric Administration's most recent data were considered by NASA to support its decisions. In his capacity as center director, Petro will outline the overall Kennedy hurricane preparations. NASA will send the first woman and the first person of color to the moon with the Artemis missions, laying the groundwork for a sustained lunar presence and acting as a springboard for astronauts to travel to Mars. Next up, the first ever planetary defense test hits asteroids. After spending 10 months in space, NASA's Double Asteroid Redirection Test, DART, the first planetary defense technology demonstration ever, successfully impacted its target on Monday. The agency had never before tried to maneuver an asteroid into orbit. Mission Control at the Johns Hopkins Applied Physics Laboratory, APL, in Laurel, Maryland, declared the successful impact. DART's collision with the asteroid Dimorphos illustrates a workable mitigation approach for defending the globe from an Earthbound asteroid or comet, should one be identified, as part of NASA's wider planetary defense strategy. The mission's successful one-way flight demonstrated that NASA can steer a spacecraft to kinetically contact an asteroid to divert it. The study team will now use ground-based telescopes to observe Dimorphos to verify that the asteroid's orbit around Didymos was altered by the impact of DART. Last but not least, DART test autonomous navigation system. The Draco imager was aimed at Jupiter on July 1st and August 2nd to test the SmartNav system. Like how the smaller asteroid Dimorphos will visually split from the larger asteroid Didymos, in the hours before impact, the scientists utilized it to detect and target Jupiter's moon Europa as it emerged from behind Jupiter. The test did not, of course, include DART crashing into Jupiter or any of its moons, but it did allow the APL-led SmartNav team to evaluate how effectively the SmartNav system works while in flight. Before this test on Jupiter, ground-based simulations were used to evaluate SmartNav. The experiment provided the SmartNav team with invaluable insight into how they interpret data from the spacecraft, among other things. According to Peter Erickson, SmartNav software developer at APL, every time we run one of these tests, we alter the displays, make them a little bit better and a little bit more aware of the actual cues we'll be listening for throughout the actual terminal event. However, the SmartNav team will be keeping an eye on how things are tracked in the image, including their brightness, the number of pixels, and how consistently they are being identified. DART is meant to function completely independently during the terminal approach. The researchers got the opportunity to learn more about how object intensities and pixel counts may change as targets move across the detector by studying Jupiter and its moons. That's a wrap for this video. What else do you think Webb will capture in the future? Let us know in the comments below. Make sure to give this video a thumbs up and subscribe to our channel for more videos like this. See you in the next one.